This chapter we are going to deal with force and laws of motion. First we will define what is a force. In a layman's language, a force is a push or a pull. We have experienced or saw the effects of force in everyday life. When we want to open a door, we have to push the door handle. And when we want to close the door, we have to pull the door handle with our hand. This means that to move a body or an object, it has to either be pushed or pulled. When a student or a player wants to kick a ball, he pushes or kicks the ball with his feet. In this next picture, we see this man again pushing the box in order to move it. In all these cases, we apply a force. Here the hand applies the force of the door, here the leg applies the force on the ball, and here is the man applying the force on the box in order to move it. So, a push or a pull on a body is called a force. Now that we know what is force, we will learn what are the different effects of force. We cannot see force, but we can see the effects of force. One of the effects of force is a force may move a body at rest. For example, when we kick a football kept on the ground with our foot, the football moves. The force applied by the foot moves the ball. But it does not mean every time we exert a force an object moves. Like in this first picture, we see this person kicking the ball, and probably after some time you'll find the ball has moved away. But in the second picture, we see this man pushing, applying a force on the boulder. But it does not mean that the boulder will move. So a force may move a body at rest. It tries to move a body at rest. A force may also stop a moving body. Like in this picture, we can see this player trying to catch the ball and stop the ball. Here's another example. When a bullet pierces through the target exerts a force on the bullet, but it fails to stop it. But it is only a force that will try to stop this moving bullet. Another effect of force is a force can change the speed of an object. For this, let us take an example of a falling object. Here we have like an object like a ball which begins to fall towards the earth. You will find that as it moves down, it moves faster and faster. And this is because there is a force of gravity that pulls the object towards the earth. So the object does not move with the same speed. The speed keeps on increasing. It's because the force of gravity or the gravitational force pulls the object and increases its speed. Similarly, if an object is thrown upwards, it will first move fast and then slowly it stops. Its speed keeps on decreasing. Here we see the speed decreases because it's the force of gravity that pulls the object and decreases the speed. In this case, as the object falls, the speed keeps increasing. Here, as the object moves upwards, there is a force of gravity that is pulling it downwards and thus decreases its speed. A force also may change the direction of a moving body. Here in these two pictures we can see, in the first picture we can see a batsman. He hits the ball in order to change its direction, and in the second picture we can see a tennis player also hitting the racket on the ball and hence changing its direction. So a force may also change the direction of a moving body. This is the last effect of force. A force may also change the size and shape of a body. In this picture we can see a child pressing a playing dough, and as you keep pressing the playing dough, the child is changing the shape and the size of the dough. In this next picture we can see how we can change the shape of a spring by exerting a force on it. We can compress it or we can stretch it. We need a force to change the shape of the spring. Now forces are of two kinds. We have the balanced forces and the unbalanced forces. Here we have an example of a ball resting on the floor, and this ball is not moving. Could you say there is no force acting on it? There are two forces acting on this ball. One force downward, which is a gravitational force, and there's an equal and opposite force acting upwards called the reaction force. We'll call it F2, and the gravitational force we'll call it F1. But although there are two forces acting, the ball is not moving, and the reason is the F1 is equal to F2. Both these forces are equal and opposite, and because they are equal in magnitude and opposite in direction, they are unable to move the body. Here they are equal in magnitude but opposite, equal in magnitude but opposite in direction, and hence they are unable to move the body. However, to the same ball which is resting now, you apply a force in this direction, and then you find the body moving. Because this force, we call it now F3, becomes an unbalanced force. F1 and F2, being balanced forces, are unable to move the body, but F3 being unbalanced, it begins to move the body, and the body will start moving in the direction of F3. So we can say that unbalanced forces bring about motion, but balanced forces do not bring about motion. Unbalanced. Let's look up at this first example. You have 5 newtons of force in one direction. In the other direction you have 5 newtons. Here the forces are equal and opposite, and hence the body will not move. The forces are balanced. We'll call these balanced forces. Now in the second example, here we have 5 newtons. However, in the opposite direction we have more than 5 newtons. We have 11 newtons. So the body will be moving in this direction. This is an unbalanced force, not equal and opposite. And because it is an unbalanced force, the body begins to move. Now in the next example, we have 20 newtons acting downwards, and we have 10 newtons acting upwards. Stop for a moment and tell me, how will the body move? You'll definitely agree that the body is now going to move in the downward direction. Would you call these balanced forces? No, these are not balanced forces. This is an unbalanced force. And because it is an unbalanced force, the body moves. Now in the next example, we have 5 newtons acting downwards, and we have 7 newtons acting upwards. And if you see, the downward force is much more. So the body is going to move now upwards. This again is an unbalanced force. And because it is unbalanced, the body begins to move. So in all these examples we have seen, when a force is balanced, it is unable to move the body. But if the force is unbalanced, it's only then when the body moves. Although unbalanced force moves the body, the balanced force is unable to move the body. But one thing the balanced force can definitely do is change the shape of the body. If I have a ball like this and I apply a force, a strong force in both the directions, you'll definitely see that the body would have changed its shape. These are balanced forces, but they are able to change the shape of the body. So just get over what we have done. What were the effects of force? We said a force can move a body, may stop a body, or it can change the speed of the body. If a body is at rest, we need a force to put it in motion. If a body is in motion, we need a force to stop it. We can even change the speed of a moving body. We've also seen that a force can change the direction of a moving body. It can change the size and the shape of a body. Then we saw there are two kinds of forces. We had the balanced forces and the unbalanced forces. Forces that are equal and opposite are called balanced forces, and they cannot move a body. But an unbalanced force which may be in opposite direction or the same direction, but they do not cancel each other. The net force is not zero. These are called unbalanced forces. In all these examples below, in this first example, we have seen that the net force is zero, hence it was a balanced force. But however, in all the examples after this, we have seen that the net force is not zero. So all the other examples 2, 3 and 4 were unbalanced force because the net force was not zero. It was the only first example where the net force was zero, and it was called the balanced force.